Hello students, today we will be learning about trigonometric and exponential integration. So we will start with trigonometric integration. As we have seen earlier that integration is the opposite of differentiation, and we know that the formula for differentiating comes for trigonometric functions are as follows. So if you differentiate sin x, you're supposed to get cos x. We have seen this, right? So it means that when we integrate cos x, if we differentiate sin x and get cos x, so it will mean that because it is the opposite, so integration of cos x must be sin x. So we can see that in here. Similarly, we have seen that differentiation of cos x is minus sin x. So if the differentiation of cos x is minus sin x, then what would be the differentiation of sin x? It would be minus cos x, because the minus would go in here, right? So that we can see in here. So with this, we can start the formula for integration. Now, the basic ones contained the integration of sin x and cos x. But what if we have an angle in here? If we have sin 2x, then we know that the differentiation formula becomes differentiation of sin x is cos 2x into 2. We have seen the power function angle formula. There is no power in here. So function is sin 2x. So differentiating that, we will get cos 2x. And then after the function is differentiated, the angle is 2x. So differentiation of 2x would give us 2. So our answer comes as 2 cos 2x. We have seen this earlier. So now, because integration is the opposite of differentiation, so if you have sin x, your integration would be cos a minus cos x divided by a, because this time you won't be multiplying but dividing. And if you have cos ax, then it should be sin ax divided by a. In this same manner, see, in this example we have sine of half x. So integration of sine of half x, we know that differentiation of sine is cos, so integration of sine is minus cos. So it should be minus cos half x as angle, and then we know that the angle is, the coefficient of the x in an angle is half, so divided by half, and then you will have a plus c in here. That plus c is mandatory for all indefinite integration. So what will we get? We will get, when we simplify, minus 2 cos half x plus c. Again, we have another example in here, which is 5 cos 3x. So what should this be? We know 5 is the coefficient, so it will play no role. It will stay as it is. Then integration of cos is sine. So if you check the PFA method again, there is no power. For integration, there is no power at all. In IGCSEs, we won't be considered or be concerned with power. So we have 5 into sine 3x. Now function is done. Now we are concerned with angle. Angle is 3x. So integration of 3x would be divided by 3 and then plus c in here. So we get 5 by 3 sine 3x plus c. In another example, we have 2 multiplied with the whole thing. So we know there is no product rule for integration. So what will we write? We will write integration of 2 multiplied with the entire thing. Why are we not removing the sign in here? Because we are not integrating yet. We are simplifying first. to reach a form that we can integrate, and then we will integrate. So 2 into cos x will be 2 cos x minus 2 into sin x is 2 sin x, and then we have plus 2 3s are 6x, and then we have dx in here. So now we will start with integration. We know that 2 is the coefficient, so 2 will stay as it is. Then we have cos x, integration of cos is sin x, so we will write sin x in here, and then minus will stay in place of minus, 2 will stay in place of 2. We know integration of sin x is minus cos x, so this multiplied with minus cos x, and then integration of 6x is it's part of algebra. We know from the previous lecture that it becomes 6x to the power 1 plus 1 divided by the new power, and then plus c in the end. So we are supposed to get 2 sin x, then this minus gets multiplied with that minus and becomes plus, so plus 2 cos x plus 6x square by 2 plus c. So when we simplify, we get 2 sin x plus 2 cos x plus 3x squared plus c as our final answer. The terms that contain sin square x or sin x and cos x multiplied, all of these forms, or sin x divided by cos x or any other trigonometric form, all of these are not in IGCSE syllabus. We cannot, there are no formulas for these. We cannot integrate them directly. We have to convert them, which we will see in the other lectures. As for now, we will be only concerned with simple sine or cos with multiple angles. So if you have sine ax or cos ax, where a can be any number, a positive, negative, or a fractional number, all of this we know how to integrate. For integration, we will divide by a. After integration, we will divide by a. And in order to handle these kinds of integration, we need to understand trigonometry. After we understand trigonometry, we can do these kinds of integration as well. So that's it with the basic integration for trigonometry. Now we will move to integration for exponential functions. So as we have seen in differentiation, that d by dx of e to the power x is e to the power of x. The exponential remains unchanged. So we have also seen that if we have d by dx of e to the power of ax, then because this is in power, so we write this as e to the power of ax, and then we multiply with a. So we do the same thing in here. Integration of e to the power x remains e to the power of x, but if we have integration of e to the power of x ax dx, then it will become e to the power of ax, and this time, because integration is the opposite of differentiation, we won't multiply a, we will divide by a and then plus c. This is the formula, a very easy formula. With this formula, we have simple sums in here. The first one is integration of 3 e to the power of minus x. So how do we deal with this one? It should be 3 as coefficient remains unchanged. Then e to the power of minus x would be the answer for the integration, and then the coefficient of x is minus 1 in this case, because if you have nothing with x in here, it means you have -1. So you divide by -1 and then plus c. Plus c will always be there in case of indefinite integration. So our final answer is -3 e to the power of -x plus c. And this is our answer. Now we will check this one, where we have integration of 5 e to the power of 2x whole square. Now we know that the formula that we have just learned does not have any square in it. So we definitely need to simplify first. So if we are simplifying, then we won't be removing the signs. We have to keep the integration sign and the dx intact because we are not integrating yet. So here we have a square over the entire bracket. So it means the square is over both 5 and e to the power of 2x. So 5 square, you will have 5 square and e to the power of 2x square. So this is going to give us integration of 5 square is 25, and then you have e to the power of 2x whole square. Now we know that e is a special number. It is just like a number, just how we have pi is equals to 3.14. E is another number, and the value of e is 1.73. So if you have a if you have a number with power, and then if you have two powers over that same number, what happens to the powers? The powers get multiplied. We have seen that if you have x square whole square, then what happens? These numbers get multiplied, right? These powers get multiplied. If you have two powers over a number, the powers get multiplied. So you will have to do the same thing in here, 2x into 2. So this gives you 2x into 2, which gives you 4x dx. Now when we integrate this, what will our answer be? What will the solution be? Because we are integrating now, we won't give the integration sign and the dx in the next line. 25 is the coefficient, it will remain as it is, and we will have e to the power of 4x as integration to e to the power of 4x, and then the coefficient of x is 4, so divided by 4, and lastly plus c. So our final answer is 25 by 4 e to the power of 4x plus c. This is our answer. Let's check out the next math. In the next math, we have this example. So it is a combination of a algebraic, trigonometric, and exponential integration. So as we can see that everything is simplified in here, so we can start the integration right away. So we are not giving the integration sign and the dx in here. So 7 e to the power x will be, 7 is the coefficient, e to the power x is the integration of e to the power x, so it stays here. Then plus 3 integration of sine x is minus cos x from formula, then minus 2 x to the power. The formula for algebraic integration is you add 1 to the power and then divide by the new power. So you add 1 to the power and then you divide by the new power, and lastly plus c. So we get 7 e to the power of x minus 3 cos x. Then you have minus 2x to the power of minus 2 plus 1 gives you minus 1, divided by minus 2 plus 1 is minus 1 plus c. So if you simplify further, you get 7 e to the power of x minus 3 cos x plus 2x to the power of minus 1 plus c. But we know that we cannot stop in here because we have a negative power. For negative powers or fractional powers, we need to write them in an orderly manner. So we have to write them as 7 e to the power x minus 3 cos x plus 2 by x to the power of 1 We know we do not write the power of 1, so we will leave it like that. So this is our final answer. If you have x to the power of a negative number, then we have to always convert this and write it as x to the power 1 by x to the power of m. And if you have x to the power of a by x to the power of m by n in this format, if you have the powers as fractions, then we know that this means the power and this means the root from formula. So nth root of x to the power of m. You have to write these conversions if you get a negative or a fractional power in case of algebraic integration. Other than that, for trigonometric or exponential integration, you do not have to worry much. These are the simple forms that you can easily do the sums in. With this, we are done with covering the exponential and trigonometric integration. In the next one, we will learn more about word problems, simple word problems.